In today's lecture session, we'll talk about this pile and pile driving, cofferdams and caissons. Well, many of you know what is pile and what is about the driving pile, but for some of you it might be really interesting to know what are the difficulties and obstacles that you may face when you think about the process. So, what are piles? Piles are practically similar to columns and they have a similar and at the same time different purpose for construction projects. Where we use the piles and why we need them. So, in certain situations where the soil is not stable and we need to put the structure on top of that soil, we will refer to piles and it requires an engineering calculations for understanding how big should be each pile and how closely you have to position the piles in the area in order to keep the structure on that soil. To discuss it further, the piles can be divided into two major categories, classifications: sheet and load-bearing piles. Well, as you can notice also from the names, the purpose and operation of the piles is different. In this picture, you see the piles that support the sheets that support the load that is coming from the sides. So the sheet piles will support the loading that is coming from a horizontal component of the soil, of a water, or any other load that we might have. And typically, these are used for dams, cofferdams, bulkheads, trenching, but the application is very wide for piles. In this picture, you see like this long wall, which is a sheet pile wall. It's supported by the piles, and the sheet is attached to the piles to support the soil pressure from one side and at the same time separate the water from the other side. Well, here we see a picture of a pile, which is a tubular pile, and the point of this discussion is to understand how these load-bearing piles work compared to sheet piles. The point of this load-bearing piles is to support the vertical load and transfer it to the media, to the soil, through its surface area, which is known as the skin of the pile, and the tip of the pile, the very bottom part that in ideal situations will reach to the bedrock and support the load that is coming from the structure and transfer it to the bedrock. But in many cases, you may realize that the bedrock will be too deep. The piles will support the load from the structure only based on the skin friction. Here you see load-bearing piles for a bridge project where part of it is sticking out from the water surface and while the other part is actually immersed into the soil for supporting the weight. Again, in this particular case, we have another type of bridge and its supports that are driven into the media, and then the superstructure goes above it. Load-bearing piles are also used not only in water but in other circumstances and situations for different projects. They come in different forms, in different shapes, in different types of material, and we'll talk about all these details in this lecture series. So, material based differences. It can be timber, it can be concrete, it can be composite. When it comes to the timber, we can think of this treated with a preservative option or untreated. So if you think for a moment about the differences of a timber pile, why would one go with untreated or why would someone go with a treated timber or this enriched with preservatives? The point is to increase the longevity of the pile itself if it's timber based because it's a natural product and over time it will get bad in quality because of many environmental effects and at the same time because of pests. So we want to prevent any adverse impact from the environment on the piles, and that's why we will practically use these preservatives. While we have this preservative treated option for piles, we have to also think about this untreated option. The untreated option will have all the negative aspects that we mentioned as positive for the treated type of piles, but at the same time it reduces the cost of a pile itself for certain applications where the treatment is not necessary, and we'll talk about it in a minute. For concrete, it can be precast, prestressed, it can be cast in place with shells, and it can be augered, cast in place. When it's precast, prestressed, it's obviously uh, done off-site, then it's moved into the construction site with the trucks. But for certain projects where either the availability of the roads do not allow these large structures to be moved into the construction site, it can be cast in place. There are some other reasons why it can be also cast in place instead of precast and pre-stressed options. And the difference between this cast in place with shells and just augered in place is pretty much the casing that can be left inside the uh, hole where we need to pour concrete. So when the hole is drilled down the soil, we can put these shells and then put the rebar, the steel, in the pile and then fill it with concrete. In certain situations, you will realize that the bottom part of this cast in place piles can be larger diameter wise than the rest of the body of the pile. The reason for that is to increase the surface area that will support the load through the tip of the pile. How you will make a larger excavation underground after drilling it? Well, it will occur due to detonation of explosives that you will place after drilling down the hole. So there will be some charge in there and it will just compact the soil around it, which will increase the volume like a ball or bubble that you can think at the bottom part of the drilled hole in the soil. And then when it's filled with concrete, it will create like a footing in there that will support the loads from the pile. From steel perspective, it can come in different shapes, in different cross sections, and each section is pretty common for a steel pipe, for a steel pile, and it also can be steel pipe. Well, while the timber, the concrete, the steel have their advantages and good perspectives from application for application in projects, composite piles are also used in the structures, because when you think of concrete and steel together, it's a composite, or it can be plastic with steel pipe core, and in this particular case you have to think about the skin surface resistances that should withstand the loads that is coming from the structure. Well, we talked about this untreated timber, and just to come back to the discussion, you have to uh, visualize the process of testing in the construction site. No matter how well you do your calculations from engineering perspective, it's always necessary to test it inside to see how actually the calculations are working in the construction site. So for this purpose, when we have to test timber piles in the media in a construction site, there is no need for using the more expensive option of a treated timber just to check when you reach the resistance that you are looking for supporting the weight of the structure itself. So for that particular case, it can rely on this untreated option, because all we need to know is if the media is supporting the load that we plan to place over it. So the lengths can vary significantly from one project to another, even from one location in the same project to another, and it all will depend on the soil analysis, soil data. So you realize that the range from 15 to 45 feet is really big, and if you think of a pile as something that you need to drive into the soil, it can be really challenging to have this 45-foot long stick and something like a hammer at the end hitting it and driving to nail it down. Well, untreated piles, as I said, will be used for testing purposes mostly, but you will also see some untreated piles used in some projects in past, which after a certain time, usually a couple of decades, will require replacement, which will basically come with a cost, and that's why it's preferable to plan the project in advance to make sure that the costs are reduced for the lifespan of the project, not only momentarily. Concrete piles. In this picture, you can see like the piles that are already driven into the soil, and it also supports the structure around it. And from structure perspective, these are pretty similar to the columns, but it has a little bit difference in it. It can come in different setups for the steel. Like you see on the left side, you see the void section that is not filled with anything, and the steel is going, the stirrups going around that opening as well, while in the other case we have a solid column shape pile that will be driven into the media, into the soil. This picture actually shows how big it can be when you think about piles. If you pay attention to the scale where we have a person standing next to it, the diameter of a pile itself is almost the height of a person standing next to it. So imagine a nail with a diameter as big as a person standing next to it, and you have to make sure that you drive it into the soil accurately so it can support a structural loads that they are coming from a big structure. Well, there are like other perspectives that you have to be really careful, like how you will be loading the pile for position on it, because as you see from the cables and from the hooks, you cannot just simply hang the pile from wherever you find it necessary and move it. You should be really careful from where you will be loading while the pile is still in rest position, so it's not in under its working position, because piles are designed to support the load that is coming vertically, not from the side perpendicular to its axis. So if you load it improperly, there is a chance that you may crack the wall of the pile itself under its own weight, which is something that no one wants to have in a project, because the integrity of the structure will be affected. Speaking of the impact that can negatively affect the quality of the pile, you should be careful while driving the piles as well, because the material that it can be used as a pile material, you should be concerned about different stages of the process. When you think of driving the pile, it's pretty much similar to the process of hammering the nail for driving the nail. So when you need to nail it, you have to be careful not to hit it so hard that you will break the core side of a pile, like you can see in this picture. Well, while there are some remedies for that, like putting these metallic gaskets on top of it and then using and loading it as initially intended, the broken pile is not something desired, because the breakage can happen not only on the tip that is visible and easy to put a gasket on, but it can also happen while the pile is in the soil, in the media. How this can happen? Like if you recall, when you drive a nail, let's say, into a piece of wood. While you are still nailing it into the wood and the nail goes into the wood, it's a smooth process, unless it's like the first time you are trying to nail it. But when you reach anything solid compared to the wood and compared to the material that can accept the nail itself, then you will realize the resistance of that particular material when you are hitting with a nail. Let's say you are putting a piece of wood on a concrete and then you are trying to nail a nail. Once the nail passes the thickness of the wood and reaches the concrete, you will feel the resistance when you are hitting the nail. So it wouldn't drive any further, but it will shoot back. So that's the point where actually in real life the piles will break. Now think of this process inside the soil. If you are driving a pile into the soil and there is a piece of rock underneath that you want to overcome and drive the pile further. When the pile is going through the soft soil, then it's nothing to worry about. But when it reaches that piece of rock, it will start resisting. And if the operator is not careful, they may break the pile. It can either break the bottom part or the top part, depending on the practice that you will exercise during the process of driving the pile. In this picture, you see the entire system that shows this cylinder pile and this hammer that is attached to its end. The yellow part, this metallic mechanism that you see in the picture. While you have to think about driving the piles carefully, you have to also pay attention to its cross-sectional shape and the positioning. So as we said, it can be H section, it can be hollow box or tubular section, or just simply as a pipe that can be either driven as is or it can be used as a casing later to be filled with a concrete. So options and choices are many and different depending on the application, and it's just a matter of utilizing the right option for a given project. Well, in here I'm showing on the picture the pipes that can be used as pile, and for any project on water it will be brought in with these large ships that you see like it's already empty because the pipes were used, but on the other side you see another platform that delivered pipes for driving into the soil. Composite piles, as I said, have different purposes, and you have to be really careful about the dimensions, the special situations, and the special situations come in conditions where it's really hard to drive the piles, because if we are using these concrete piles which are really brittle, the composite may not give up that easily, and it might be advantageous to rely on composite piles. In this picture you see the mechanism that is used for positioning the pile, which is basically a crane. There is nothing fancy about it. It's just a pile lid that you should notice in the picture, where on the middle part of this lid you will notice the hammer itself, and then in the bottom that's the pile that is positioned for driving it down into the media. And again, if the operator is not careful, then they can break the pile. But there is one important thing to notice for the broken piles. In real world, like when you are driving a nail into the wood or wall or anything else, when you are not successful, and let's say you bend the nail, you will be able to pull it out and then put another nail and then continue the work, right? For piles, that's not the case. If it happens in the first few seconds, then it might be possible to loosen it up and pull out the pile from its position. But if it's already driven enough for it to get stuck in there, then there is no way that the machine will be able to pull out a pile and drive another one. Let's say if it breaks down, there is no way that you will be able to pull it out and then drive another pile. So at that situations, it might be necessary to do some structural change. So it will require redesign for a localized solution in order to move the location of a pile. For the forces that resist the driving process, you can think of it as the loads that will support the structure in its place, or vice versa. Like if we are looking for the forces that will keep the structure in place, are the forces that you have to overcome in order to drive the pile into the media, right? So the total resistance of a pile for penetration will be equal to the sum of the forces produced by the skin, friction, the surface area, and the end bearing, the tip of the pile itself. So these load-bearing piles, as I mentioned in the beginning, work with two fronts, so that the tip and the skin friction. Depending on the size of the project, you might need to test piles before you can continue with your actual engineering calculated numbers for the piles. For that purpose, like you have seen for that untreated pile situation, you might be using also some composite piles or concrete piles or steel piles in order to test it. What you will need to do is to drive some piles and then have these jacks positioned for loading the test pile to see if it's actually supporting the load that you calculated from engineering design stage, or it's giving up and you need to further drive it down in order to support the weight. Because as I said, in some situations that bedrock that we try to reach will be far deeper and we will rely on the skin surface friction. The hammers. What we need to know about the hammers. There are like different specifics that we have to observe and analyze in order to be able to drive the part successfully. Depending on the subsurface conditions, different types of hammers will be used, and the different types of hammers actually vary because of the function of the pile hammer itself, how it generates the energy, how it drives the pile. But the final idea is really simple. You should be able to generate enough power, enough force in order to drive the pile down the soil. What are different types and different options for the pile hammers? Well, first option is called drop, which is pretty simple, straightforward process. We'll talk about each of these options individually. Single acting, steam or compressed air. Then the double acting. We'll talk about the differences of these two, and it's pretty easy to understand what's the difference and why we have to use one versus another. We'll talk about it. Differential acting, steam or compressed air, diesel-based, hydraulic or vibratory drivers. So let's discuss each of these individually, or some of these individually, because some are really similar to each other and there is no need for discussing every single item in these hammers from the mechanical perspective. But for the information, this is the drop hammer. When we talked about soil compaction, we talked about dropping the weights from a certain height. In this setup where we have this drop hammer, what you see in the picture on the right is the cap that is positioned on the top of the pile, and then the rim that is hanging over the crane through the lid. So when it's dropped because of a free fall, it hits the pile and drives it down. Why we need to put the pile cap is just to prevent the surface, the tip of the pile from any damage due to the impact of weight that is hanging on the top. Let's talk about the single acting hammers that can be either like steam or compressed air based. What you have to pay attention to in this setup is the components for the single acting versus double acting that I will show you in the next slide. But let's understand what's happening in here in this setting, so it will be easy to understand the next one without any difficulty. What we have in here, what we see in here, we have this cylinder that allows this piston to go up and down inside. Then next to it, we see this valve that allows an inlet and exhaust. Well, you realize that the piston is attached to the ram. That's the weight, the free fall weight that we talked about in the previous slide, that hits the pile in order to drive it down the media. So what happens when we have this inlet part open? We can push the compressed air in or the steam in, which will drive this piston upwards. Once it's in its upper position, then we can close the inlet and open the exhaust. Once the exhaust is open, the compressed air or the steam will be able to escape, and then the ram will fall under its own weight and hit the pile and drive it down. A simple hammer mechanism that basically uses the force to drive the pile down. But now, in contrast to these single acting hammers, we can also increase the power and utilize the time from a similar system much more efficiently, because if we have this compressed air or the steam, why to lose it, right? So if you go into this double acting hammer, it utilizes the air, the compressed air or the steam both ways. So let's understand what's happening. We have pretty similar setup. We have the ram, we have the piston, we have this inlet valve, but now it's positioned in the middle, the inlet that is connected to two valves. So the upper and the lower valve that allows the air or the steam to circulate. So what happens in this setting? When the inlet is allowing the lower chamber to get loaded, it moves the ram up, like we talked about the single acting hammer. But when it's closed, now it can allow the air to flow backwards to the top part of the piston. So while the weight of the ram is driving down that entire system to hit the pile, now the air, the compressed air or the steam, can be used to further accelerate the movement of the piston for the downstroke and hit it even harder. So pretty much this is the double acting hammer mechanism compared to the single acting mechanism. And you understand how it's working and what are the benefits of this. Differential acting hammers are pretty similar, that I don't want to talk about it for too long, and it's operation wise is pretty similar to these hammers. For diesel, it's actually utilizing the energy from the fuel and the explosion process, that is generating the energy in order to drive the pile down the media. We will talk in more detail about this one to see how it's working, and the idea is again to have this process of moving the ram up and down and driving the pile down the media. There is nothing complicated or nothing difficult about this process. Again, the idea is really simple. It's just about moving this big structure into the media. So we need to generate enough power to get the job done. So impact compression, impact and explosion energy is driving the pile down the media when we use these diesel hammers. how it's working. So in this picture, what you see is that white portion is in the bottom part is the pile. Then we have the hammer mechanism attached to the lid, because this frame that you see on the side is the lid that is holding the system intact with the pile itself. So for the first step is to raise the piston to start. Then we need to put the fuel in, the diesel, and then we have to compress it, so basically lowering the piston down, and then ignite the fuel that is in there. So when we ignite the fuel, what happens? The force is transferred to the pile itself and to the piston that is on the top part. Well, while part of that energy is used for driving the pile down into the soil, part of it is used for moving the piston upwards again for the next cycle. So once it's up for the next cycle, we see that we can just put the fuel again and continue the process again. When it comes to diesel hammers, we have to pay attention to its energy utilization, because fuel usage will significantly vary depending on the power that we are looking for. So what you have to notice in this short information that is available on the slide. Let's say it's Delmac. This is just like a brand name of one of the manufacturers. It doesn't matter actually. We can think of this power that we are trying to generate. So 10,500 foot-pound will actually utilize 0.7 gallons per hour. Then if you go to the next level, it goes to 58,248 feet-pound, and it's utilizing 2.11 gallons per hour. Likewise, if we continue the comparison, we realize that for 300 feet-pound, we are using almost 8 gallons per hour. Now, if you compare the power that we can generate from a different type of hammer and its actual power utilization, the energy usage, the fuel usage, we notice some important aspects that can help to save fuel if a particular type of hammer can be used for the operation. Obviously, we wouldn't go for a 10,500 foot-pound hammer if we need to use 300,000 foot-pound hammer. But at the same time, we will not do it vice versa. So, for certain instances, if we can utilize a larger piece of equipment in order to get the job done, while a small one can do the job, we also have to pay attention to the comparison. So if we compare the first two options, 10,500 versus 58,248, the difference is almost 5 times, to round it to the safe side, right? But if we compare the fuel utilization, it's 2.11 over 0.7, which is what? 3 times. So 2.11 over 0.7 gives us about 3 times difference. So 5 times versus 3 times. So with such parallel, you can think for any other instances, although in this case I have like large difference and we will not be able to utilize, but I wanted to show these exaggerated differences to bring it to your attention that some simple comparison may save you significant amount of energy when it comes to picking a construction equipment piece. You can use similar logic for any other instances, so make sure that you compare it. And there's a trend in the industry for moving to these hydraulic hammers, because hydraulic hammer operates based on this differential pressure of the hydraulic fluid instead of the compressed air or the steam that we talked about in previous instances. And there are certain parameters that you can pay attention to, even though all of these numbers are important when it comes to the choice of a right hammer for its utilization. There are certain things that I want to highlight for your attention. So the rated energy that we talked about that we want to generate, right? So in this particular case, this particular piece, this particular hammer has 42,000 feet-pounds. Also for the metric unit, you see the numbers are given too. Then we have to pay attention to the speed, the blows per minute. How many times? Well, you notice that it can go really quickly. 37 to 55 blows per minute. Typical operating weight with cap 8,710 pounds. This is for the bare hammer, like if you think of the structure that we talked about. And then the operating length. So the top of the pile and the top of the ram. Even though we mentioned that the piles can be in different dimensions, ranging from, for the timber, let's say 15 to 45 feet, right? So, or like let's say we have 40 feet concrete composite pile that we need to drive. We have to pay attention to the height. That in this case we have this 27 feet and 9 inches, which will be a limitation of choice. So we will not be able to use this particular driver for starting the process of driving the pile. In certain situations, you will notice that for projects, you will need to choose one type of hammer to start the process and another to finish the job. Well, that's because of these technical parameters, but at the same time, you have to relate it to the soil conditions, and in a minute we'll talk about those conditions as well. Vibratory piles. These are used for moving these piles into water-saturated, non-cohesive soils. Because of that media, it can be really preferential to use these vibratory piles and drive the pile down. In the picture is the pile that is standing. Actually, it's positioned through the crane and the lid. And on the top, you should notice these square shapes at the end of the pile. That's the vibratory pile driver. Okay. The system is simple how it operates. We have these eccentric weights that is rotated through these motors, through these engines, and through these rotations, it generates the impact. And that impact basically drives the pile down the media. Well, this is an actual picture of a vibratory hammer. These come in different sizes and powers, so you have to be really selective what is the right one for a particular job that you will have in hand. And these vibratory hammers can be driven by hydraulic or electric motors, so the supply of energy can differ depending on the model, depending on the manufacturer and the make, so make sure that you understand how you have to choose it. Well, when we have to drive the piles, we have to make sure that these are positioned properly, because as I mentioned before, if something goes wrong, you wouldn't be able to pull it out and start again. Think of, again, nails. If you didn't position it properly and it goes under angle, you may decide to pull it with pliers and just like reposition it and drive again, right? That wouldn't be the case with these piles. So you have to make sure that it's properly positioned right from the beginning. And depending on the operation of a pile, the positioning will be different. We may also decide to drive it under certain angle if necessary, just because we need to support the loading forces. In this case, we see these three different positioning, and like the first one is the vertical option, while for other two cases we see that machine can position it under angle depending on how you will put the machine in the construction site, the crane, and how you should position the pile itself for driving it. Well, how we will be fixing it is due to this pivot point of a lid that can be attached to the crane, so you will be able to change the angle of a pile itself, while from the bottom part it will use these attachments to fix it to the base of a crane. And in this picture you see that entire system where we have the pivot point, and in the bottom part we have this hydraulic kicker that controls how you can move the pile and change the angle for its final positioning for the fixed lids. And this is the actual picture of the process. You see the lid that is attached to the crane itself, you see the hammer on the top of the pile, and you see the arm that is basically keeping the pile to its position, and it's fixed to the base of the crane, the machine itself. Lids that are not attached at their bottom to the crane or driving platform are known as swing lids. What is it about? So it's actually hanging from a crane. That's simple. The lids and hammer are usually held by separate lines for this situation, just for the stability purposes and for the ease of operation. In this picture you notice the lid, you notice the cylindrical pile, circular tubing pile that we have, and the hammer that is hanging from the crane for positioning. Well, it's really a big pile. Like, think of this, the dimension that I have on the slide, like 54 inches concrete cylinder pile that we need to swing, position it, and drive it down the media. So it can be a really tricky process, and it's really easy to break these piles if it's not done properly. In order to position it properly, we have to put these lids, which will have these sharp stabbing points, to immerse it into the top layer of the soil to position itself properly. Then put the pile over it so it will be really stable and wouldn't change the angle while you are nailing down the pile. Positioning is really important, and the templates can be a great help when it comes to driving the piles. And if it's done properly, then the process can be really fast and without any complications. If it's not followed properly, the best practices, then it will take really long time to drive the pile. In this picture you see like the system where that is used for driving the pile, so later on the structure will be positioned. Coming back to the discussion for loading the piles, if you notice the cables are positioned at certain locations on a pile, and if it's not done properly it will be easy to crack the pile, the body of the pile, and it wouldn't serve the purpose. From your structural courses you can do some analysis and realize what's happening and why we need to pay attention to the location from where you will be putting the hooks around the pile in order to move it. So as a hint, pay attention to the moment diagrams, and it will give you an understanding of what can happen and why you have to pay attention to the location of loading the pile for even a small movement in the construction site. So pay attention to the flexural stresses and you will see why it's important. Some pointers that will help in process of planning. For concrete piles, the weight of the hammer ram, that weight that actually hits the pile itself, should be 1/3 of the pile weight. If it's lighter than that, you will be facing difficulty of efficiently driving the pile, and sometimes it wouldn't be even getting into the media at all if it's like really light hammer that you choose for the job. Likewise, if it's really a heavy hammer, then it might be difficult to control the entire operation and get the pile safely driven into the media. Easy to start the pile with an air hammer, because if you recall how it's working, the mechanism for that compressed air hammer, it's easy to start the process with it. If we have these diesel hammers, it wouldn't start on a soft material, because if you recall, it's operating mechanism, it's looking for some compression. If we do not have a compression, then the ignition, then it wouldn't be easy to drive a pile through these diesel hammers. That's why I mentioned that for certain situations you will need to start the process with one type of hammer and then continue with another. So there are like different factors to consider for using different hammers for that same pile. Either the height can be a limitation for a particular type of hammer, and you may decide to use one type or another to start the process then continue, or the media itself can be an issue, or combination of these things can be an issue for choosing one type of hammer for the start of the process, then another one for finishing the job. We have to make sure that we are properly positioning any type of pile before uh, driving it down into the media, and you have to keep in mind that moving the piles is extremely difficult because it can be really long. You might have a windy conditions, even though it might be hanging from a crane. It should be done really carefully without traveling with the piles. The process, it can be really fast or it can be really slow to drive the piles. If the conditions are good, then 45 to 50 feet piles will be driven really quickly within 5 to 10 minutes, but for hard materials, for hard cases, it can take 4 hours just for one pile. Now imagine the scheduling process if someone is not aware of this information and they just simply plug some numbers in. And there are like projects where you have thousands of piles that you have to drive into the media. Basically, you have to make the soil so stable that large structure can stand on it, because your client decided to have that big structure in that unfavorable condition, and you have to stabilize it first and then guarantee its stability for years to come. So the time can be a significant factor. So 5 minutes versus 4 hours for one pile when you have thousands of piles to drive can be a big difference. And don't forget about the safety. So no matter what is the importance of the project, no matter how late you are on the project, do not risk the safety. If you see someone who is actually risking their safety for the project, slow them down. Tell them that what is the right thing to do and how to do to follow the best practices for the safety purposes, and only then you will have a successful project. Other than these uh, piles, we have to also understand that there are like other structures and strategies that can be utilized in order to build construction foundation stable enough, solid enough to support big structures, heavy structures, if the soil conditions are not favorable. So first, what we need to do is to do the surveying to understand what are those details, how we have to make our decisions, what we have to know about it. Next, we have to do the soil analysis and then think about these caissons. Caissons are another type of structures that can be used for a solid foundation. Now, this is a picture of a caisson. It's a circular form structure that you see the rebars, the metallic part, that is shelled from interior side and from the exterior side and then filled with concrete. So the idea is to build this system that either can later be taken into the final positioning point in the water and then immersed into the water, or it can be built in place step by step and then lowered it into the water and the soil under the water. These are typically used for the purpose of building foundation and support for bridges, and the system is pretty interesting and really exciting. Another picture that shows how big a caisson can be. You see this setting that has this bottom part as the soil where the construction equipment operate, excavate the soil, and the caisson penetrates into the media under its own weight. Because it's big structure, huge, massive system, really heavy, if the soil is excavated from beneath the edges, it will slowly immerse into the media. And this is just one option of utilizing these caisson systems. Another option from schematic representation perspective can be the following, where you can think of a caisson as upside down turned cup that you have, and you need to immerse it into the water. If you tried it, then you know that that air inside the cup will resist and will push the cup upwards, right? And you will need to use some force in order to push it to the bottom of a container, or in a large scale into the bottom of a river, of ocean, or wherever is the structure going to be. Okay, so in this system you see this upside down cup mechanism, which is not open on the top and is pressurized to keep the water off this space. And in that workspace that you see, if it's large, then construction equipment can operate. If it's small, then people can operate directly on that floor, excavate, and then under its own weight, it will continue penetrating further and further, deeper and deeper into the media. Well, this is like pressurized system, and it's really unsafe condition for any human being work continuously. So whenever you are planning for such work, you have to be concerned about the timing that you will leave one shift in that condition. So just a couple of hours will be more than you can leave a human in under that pressurized system to operate. So you have to have multiple shifts, multiple personnel in order to keep the work going. Otherwise, you will need to have interruptions, which will affect your productivity and slow down the completion time of the project. Even for the wells, this process was utilized for many centuries for building these caissons for the wells, for getting the water. And in this picture on the right, you can notice that the system is in place and the person is actually excavating in the bottom, and under its own weight the system is going further and further and deeper. Well, the process is interesting, and really many projects are based on this setup, this approach. And on a smaller scale, where you do not operate a construction equipment inside caisson, these systems for piles, for sheet piles, for load-bearing piles, and so on and so forth that we talked about, can be used for cofferdams. And for cofferdams, the point of using a cofferdam is to separate an area from a water. Once the construction is finished, it will be covered and it wouldn't look as ugly as it is in the picture. But after all, it prevents the water from getting into the construction site and allows work to be completed. In a similar note, because I mentioned that these systems are used for large structures, I want to bring your attention to this Akashi Kaikyo bridge in Japan. Usually show the video in the class for the construction of this project, but at this point I will just simply recommend you to watch the construction videos of this structure, and it will give you lots of insight about the innovative ideas and what can be done, how it can be done, how the caisson can be built actually for a large mega project, and then the entire bridge can rely on that structure for its final positioning.